Welcome back to the AI Research Roundup. I'm your host, Alex. Today, we're looking at a paper from October 14th, 2024, called Agent as a Judge, Evaluate Agents with Agents. The core idea is a new framework for evaluating, agentic systems. These are AI systems that act step by step to solve tasks. This Agent as a Judge framework uses these agentic systems to evaluate other agentic systems, an extension of the LLM as a judge idea. It's designed to provide much-needed intermediate feedback because current methods often just look at the final result or require too much manual effort, potentially leading to better reward signals, which are crucial for these systems to learn and improve. And for those who want to see how this Agent as a Judge framework is actually put into practice, the authors have made their code available on GitHub. You'll find the core implementation there, along with scripts for running evaluations, generating those crucial reward signals, and the benchmarks, which are essentially standardized tests used to measure performance. Okay, so, gents, Figure 1 really helps visualize what we're talking about. It compares 3 ways to evaluate AI systems. On the left, you have LLM as a judge. Here, a user asks a question. 2 different large language models, or LLMs, provide answers, and then another LLM, the judge LLM, picks the better one. It's often a simple comparison. Then in the middle, we see the Agent as a Judge framework. This is for more complex, agentic tasks. Those step-by-step problem-solving scenarios we mentioned. 2 agents try the task, and a judge agent evaluates their process and outcome, looking at things like generated code and whether requirements were met. This is shown as an upgrade. Finally, on the right, there's Human as a Judge. This is similar, with humans evaluating the agent's performance. The figure suggests Agent as a Judge can replace or imitate this human effort, which, as the paper notes, can be very time-consuming. Alright, Figure 2 gives us a closer look at the DevAI benchmark, that new testbed for these agentic systems. Panel 1 shows word clouds from user queries, and you can see terms like dataset, model, and results are really prominent, which makes sense since DevAI focuses on AI development tasks. Panel 2 then shows the length of these user queries. They range from 69 to 164 words, with a couple of longer outliers. Panel 3, number of tags of user queries, shows that supervised learning, which is a common way AI learns from labeled examples, is a dominant category. And finally, Panel 4 details the mentions of models, highlighting frequent ones like support vector machine classifiers or SVM classifiers, which are algorithms that find the best way to separate different groups of data, and long short-term memory models, or LSTMs, a type of neural network good at remembering information over long sequences. Alright, so building on our understanding of the DevAI benchmark, Figure 3 now shows us a specific example task from it, called Task 51. We see a query at the top, which is what the user is asking the AI agent to do, in this case, planting secret messages in images. Below that are the requirements like R0, R1, and R2. Critically, these have dependencies. For instance, R1, ensuring images are 1080p, depends on R0, setting up the script. This creates what's called a directed acyclic graph, or DAG, which is essentially a set of steps where some tasks must be completed before others can begin, without any circular loops. Finally, there are preferences, which are optional guidelines. Now, Table 1 gives us some initial performance numbers for these AI developer agents, Meta, GPT, GPT Pilot, and OpenHands, when they tackle tasks on that DevAI benchmark we've been discussing. This table compares them on metrics like average cost, average time, and the amount of data processed, which is often measured in tokens. Tokens are basically small units of text, like parts of words or individual characters. We see some interesting trade-offs. MetaGPT, for example, was the most cost-efficient, but it saved the fewest code files. OpenHands was the priciest but also the fastest. Meanwhile, GPT Pilot took the most time but generated the most output tokens and saved the most code files. Okay, so after looking at those initial cost and efficiency metrics, Table 2 shifts to how well these agents actually performed on the tasks according to human judges. This is the Human as a Judge evaluation, we see metrics like requirements met I, which is for independent requirements, and requirements met D, which means requirements met considering those task dependencies we saw in the directed acyclic graph. The results are quite telling. GPT Pilot and OpenHands met about 29% of requirements when dependencies were factored in, while MetaGPT only managed about 6.5%. And look at the task solve rate. It's very low, just 1.81% for GPT Pilot and OpenHands, and 0 for MetaGPT, showing how challenging DevAI really is. Alright, so following on from those human evaluation scores, Figure 4 really underscores an important point about that process. It shows the disagreement rate, which is basically the percentage of times different human evaluators, or combinations of them, didn't agree on whether an AI agent met a specific requirement. We can see 4 different bar charts, each showing comparisons like between evaluator 231A and 38BB, or 38BB and CN90, and so on, for each of the agents, MetaGPT, GPT Pilot, and OpenHands. The key takeaway here is the variability. For instance, looking at GPT Pilot, the disagreement between some pairs of evaluators is around 20 to 30%, and even higher for OpenHands in some comparisons. This variability highlights how a single human's judgment might not always be the most reliable benchmark. So given that variability, and the potential unreliability of a single human's judgment, the researchers propose a new approach, and Figure 6 gives us an initial look at this. It's a diagram of their agent-as-a-judge framework. This is a system designed to use AI agents, to evaluate other AI agents. You can see it has inputs at the top and outputs at the bottom. And inside, there are several core components, like planning and memory on the sides, and then a central pathway with modules like graph, locate, search, retrieve, read, and ask. These are all designed to work together to assess the agent being tested. These components within the agent-as-a-judge framework really aim to systematize how we assess AI agents. The key idea from this research is that human evaluations can vary quite a bit, and this agent-as-a-judge approach offers a potentially more consistent and scalable alternative. This is crucial as we develop more sophisticated AI agents and need reliable ways to understand their performance. Alright, that's our AI Research Roundup for today. Thanks for joining me, I'm Alex.